Okay, we're going to get started with the combined philosophy and abstract talk. And this one's actually one of my one that I've been anticipating for a while, so I really look forward to this one.
Oh God, no pressure.
No pressure. But I think it's going to be highly relevant for both tracks, which is why I asked everyone to come here. It's also supposed to be quieter. I kicked everyone out over on that side. So hopefully everyone can hear, including in the back. And I'm going to turn it over to Frank and Chris.
All right, thanks. Yeah, so I'm Frank Duff, and this is Chris Korban. We work with the MITRE Corporation. I won't go into the big backstory for them, but we're this unique role between government and commercial. And the talk today, right, in the agenda, it's got a really long title. Forget what it is. This title doesn't mean a whole lot. Really what you should be thinking about in terms of what we're doing is we're talking about the evolution of offensive testing for defense purposes. So with that, I'm going to start talking with some stuff that shouldn't be groundbreaking for anyone here. And it actually echoes a lot of the talks that we heard yesterday in terms of what red teaming actually is and the limitations there of it. But it sets the stage for our background, right? So 5 years ago, MITRE stood up this living lab experiment on our operational networks, about only like 200 nodes or whatever, but other talks on that. But the point of it was trying to figure out how can we detect the APT more quickly than we have historically, right? So when the research started, the median dwell time was, I think, over 200 days. We're still at around 90 days, so still room for improvement, but things have gotten a lot better. But we were trying to look at how do we look at host data, this new idea, how do we look at host data to find the bad guy? And again, 5 years ago, that was a new thing. Now we have tons of EDR solutions. But we started teasing out some ideas, developing analytics, doing those types of things, building out new sensoring because, again, the EDR solutions didn't provide. And then we're like, well, how do we actually know if it's working or not? Let's do this thing called red teaming. And red teaming existed already. That wasn't our idea by any means. But Chris, the red team, comes in. I'm blue team. I've developed some analytics. First one went great, right? Half of our analytics actually were some of our hypotheses that we just shot wild darts at were actually coming together. We were able to piece together enough of the information, and that was good. 4 months later, we did the same thing again. Defense had come in, and we had tuned our analytics. We had filled in our gaps. Red team came in, completely changed all their ways of executing, right? They changed all their GTPs. We looked like completely fools, like it just utter failure, right? And we're looking at it like, this is a research project. We just complete failures. How are we going to get funding? Well, fortunately, MITRE had a little bit longer leash with us. But we had decided, well, 4 months was a long period of time. We got destroyed. Why don't we destroy ourselves faster, at least? So we decided to condense the timeline. And instead of doing it every 4 months or so, we decided to do it every other month. And these were relatively large activities. But what this encouraged, rather than actually tons of wounds, was actually a much more collaborative red and blue team perspective. This kind of mentality is one that's shared by like the Chris Gates and Chris Nickersons of the world who pontificate about purple teaming and things like that. So great idea, right? Blue and red working together. Blue embracing a red mindset, being able to test their techniques out. More recent things, atomic testing, further helps this, right? You can now unit test your analytics and continue to build up new capabilities. So purple teaming, atomic testing, all those things were great. So we knew kind of generally a methodology that worked. During this time of quick iterations was actually when MITRE was able to establish a couple knowledge bases that evolved. So ATT&CK came out of this entire exercise, so attack.mitre.org, as well as the Cyber Analytic Repository, a much lesser known because it's not as active of a community, but still a pretty valuable resource, car.mitre.org, and that's the blue side of the house. And a number of other research projects like the automated red team Caldera and Cascade and things you can find on GitHub. So won't go into big detail there. But fast forward 5 years, we work for the U.S., or we don't work for the U.S. government, but our customers are the U.S. government. They're embracing the fact that they need to look outside of their own doors to find innovation. Let's go out for the commercial world. Chris and I stand up this project that tries to also tackle that problem. How can we get commercial technology into our sponsor bases more effectively? Well, rather than just start at ground zero, we're like, well, let's start where we know. Let's start with EDR products. When this really stood up about 2 years ago, EDR was out, but just really hitting its full stride. There's a lot of combination of technology types. So next-gen AVs were claiming that they had EDR capabilities. DLP solutions were claiming they had EDR capabilities. EDR capabilities were saying that they have protection mechanisms or deception mechanisms. So there's this big cluttering of this domain. At the same time, we had all these government organizations, we had MITRE trying to figure out what are the technologies that we should consider? How do we understand? How do we test? How can we actually engage? And how can we make sure the solutions that we're getting are really optimal? So this effort stood up. Let's try to start evaluating some of these technologies. Let's understand what they can do so that we can better inform both our government sponsors who want to buy things, but also inform the vendors so that they can improve their products. Because while they might all think that they're great, they all have their gaps. So again, coming from the background that we came from, we wanted to be able to leverage what we already knew. And that largely came to ATT&CK. We lived and breathed it. It was developed 2 doors down from us from a great team. We've contributed to it. It was our way of articulating what red and blue could do back when we were evaluating our environment and evaluating our capabilities. And we thought that it's also a very good way that we've been able to have success articulating what we were doing to the US government, and thereby we could articulate to the vendors. Fortunately, there's a lot of commercial acceptance of ATT&CK these days too, which kind of helped the cause. Additionally, ATT&CK lends itself very well to repeatability from the standpoint that it was originally developed in an Excel spreadsheet. Super gross, but it had this nice little tabular format, and even when you go to ATT&CK, you can see this thing called the ATT&CK matrix. You see the cells, like you can click on them, well, you can't click on them yet. Future version, you'll be able to click on them. But what people are doing is shading in cells based on their capabilities, right? So if you have a green cell, it's a coverage. If you have a red cell, it's a gap. That lends itself very easily to being able to measure improvements. So where you test your capabilities out, you executed these techniques. This one was red. Next time you come in, you do the retest, that turns green, you know you've made an improvement. So you can see this over time, you can see your growth. So ATT&CK as a criteria, great starting point. So everybody here should know the period and pay by now, so I'm not going to go into it by details. But the key point here is ATT&CK really focuses on those TTPs. One thing we didn't want to get captured into is the tooling, right? We don't want to focus on whether they're using WCE or whether they're using Mimikatz from the red team capacity. We're trying to focus on the high-level behaviors. So that way, our defenses are, in a way, the most resilient they can possibly be. So move away from IOCs, use them to pivot through data, but focus on behaviors is really where ATT&CK comes into play. So we know ATT&CK is the way that we want to be able to evaluate the products. But when you think about ATT&CK, so ATT&CK right now is about 200 different techniques that adversaries use, ever growing. So if you have 200 different techniques, and then each one of those techniques has multiple implementations, so that's one of those things that ATT&CK doesn't tell you right now, but you can think of every one of those techniques, red team could actually implement in a couple different ways. And so it's very tempting to color in a green matrix because you have one type of detection, you really have to do multiple. So you have 200 times, let's say, n. And then if we're going to be doing this at scale, we want to actually bring in multiple vendors. So conservative estimate of, let's say, 10 vendors. That's a lot of testing. That's a lot of resources. And that was not going to be anywhere near the speed that we wanted to be able to execute. So instead, what we chose to do was try to identify a subset of techniques that could then formulate our test that would scope it down to a more manageable state, would provide still some level of repeatability because we could execute the same chaining in the same order more or less every time. And it also kind of provides the end-to-end life cycle of the attack. One of the things about attack, when I say life cycle, I'm literally cutting the life cycle in half and only looking at the post-exploit portion of this. But for EDR, perhaps that works. So adversary emulation is kind of what we settled on. One of the things I will differentiate here from some of the other, like adversary simulation and things like that, emulation to us specifically goes back to that attack mentality of trying to mimic adversary behavior, not necessarily repeat it. So it's not about creating the same IOCs. It's not about using the same tools. It's about creating representational effects so that way red team can go and implement as if they were a red team or as if they were an adversary, but not be prescriptive about it. So emulation versus simulation, slight little nuance. So what makes a successful emulation? Well, one, as I said, it makes it real, right? So this is kind of where we've been at today. We've got this ability to make, or to do EDR assessments or even environment assessments or other product assessments based on the attack framework, where we use this common methodology. We've made it real. It's not about just red teams pushing the agenda or pushing the ball forward. It's about really creating this is a threat, let's defend the threat. It's end-to-end because it's working from the point the adversary gets on to the point that they're doing their exfil or whatever their end game is, and it's now a repeatable model. So that's kind of the high, lofty view, and now I'm going to turn it over to Chris, who's going to talk about the actual implementation and what we're doing with attack right now to make this a reality, and this gets into more of the ops portion of it.
Just a quick show of hands. Who here has, at least in some way, shape, or form, heard of attack or used attack or just, okay, awesome. So one of the big problems that we were trying to deal with, and I'm going to sort of loop back to something Frank was saying earlier, is we have different vendors that come in, and we need a simple, well, not a simple, but a straightforward, repeatable way for us to be able to measure how well they do, and based on the metrics there, be able to compare them as close as possible, apples to apples, with other vendors. This should help us with doing to do quite a good amount of things. One of which is where do we spend our money, for example. A, and then B, is this vendor actually catching what they say they catch? I mean, if you were to listen to some of these marketing slicks, you pretty much, cybersecurity is solved. We can all go home, and it's a nice fun day. But one of our approaches was basically to take these red teams that we did and break them down into repeatable emulation plans, adversary emulation plans. One of the first adversaries that we were familiar with, this is what we started with, was our internal red team. That was pretty easy and opportune for us because you could go ask the red team member, hey, what were you doing for lateral movement? What did you think? Why did you do that? Etc. So taking that and breaking that into an actual plan with figuring out their MO and their tooling, that's, we have full knowledge there. However, that we didn't want to stop there. We didn't. We saw that there was a chance for a little bit better, I guess, research, a little bit better work in maybe let's going back to step 0. Assume someone doesn't have this dirty knowledge of, or their own internal red team, or maybe the best intel sources. So what we decided to do was take a look at our sponsor base, the people that we work with, the people that come to us for information, and take a look at what their threat looks like, who's actually actively targeting them, and maybe try to emulate some of those adversaries. And in doing so, we landed on any pretty much numbered APT. And we chose 2 to start off with, APT 3 and 29. And the reason we chose those 2 is actually pretty important because by choosing 3 and 29, we were able to sort of span the difference in both complexity and freshness of attack. Well, those are the 2 things: the freshness of their attacks and how the freshness of their campaigns and how soon or how long ago it was, versus how complex they were. APT3 would come in and pretty much once they're on your network would just use the tools of the land and sort of just fly under the radar. Whereas you have APT29 coming in and deploying some of the newest things which were just released maybe a couple weeks ago. They've already been weaponized in their own custom tooling and deployed. So this is sort of the process you could see here that we sort of like 4 steps that we sort of landed on for this adversary emulation. And the first one is threat intelligence acquisition. This one was, like I said, we focused on everything that's free, open source, and just basically Googleable. We didn't use any dirty knowledge. We didn't have anyone on the team that had worked in this sort of area before, other than just being on a general red team and intimately familiar with attack. And working with intelligence and sourcing this was actually, and we didn't use things like any FireEye or any subscription-based intel. We didn't pay for anything, in other words. So this was definitely more difficult than I thought it would be. There's a lot of intel out there, and the quality definitely differs. It varies widely. For APT3, we had a good chunk of data that was really focused on IOCs, and that really wouldn't really help us much if we're trying to emulate said APT. what we were looking for was behavior. We were looking for their TTPs. We were looking for things that, they have a hard time changing if they knew we were looking for. Within that intel, we would, like I said, we would try to find these techniques at TTPs and extract them. Once we did extract them, we'd map them to the attack matrix here. I know you can't see, much of it, but I hope you're familiar enough with it to be able to, assume or just get the sort of idea. But we extracted specific TTPs, mapped those to attack, and start to form the MO and start to form what this adversary is capable of doing on your network. Second thing, or the third thing we do is to develop the tools and analyze adversary MO. Developing the tools, that's just basically, okay, we've extracted techniques. Well, can we do these techniques ourselves? Do we have access to an offensive testing framework, Cobalt Strike, Metasploit, etc., that has modules that allow us to do these specific TTPs? Depending on how new these specific TTPs are or behaviors, there may not be tooling for them, so you may need some dev here. And also the second part of that, which was analyzing the MO. This is basically try to determine what the MO of the adversary is once they're on your network. Like as Frank was saying, we don't really, we do focus pretty much almost exclusively post-exploit. In other words, once they're on your network, how are they moving around, laterally moving, privilege escalation, and all that. And that's really where we want to focus. And finally, setting up C2 infrastructure and then actually going ahead and emulating the adversary. So those are the 4 steps basically for this. What you'll realize, and what we realized, is once we start coming up with just various different MOs for various or different adversaries, you'll start to get what you see here as a pretty general, I guess, just phase workflow for, I guess, an adversary. You got your phase 1, things they do before they hit the network. Phase 2, things once they're on the network. And then phase 3, just action on objective, collecting data, exfilling, etc. If I was to give this to a red team and tell them to go ahead and execute this 5 different ways, I'm not going to get 5 different actual implementations of it. I'll probably get 6 or 7 because a couple of them felt they needed to go that extra mile. But so this isn't, if we're looking for basically easily repeatable and apples-to-apples comparison, this doesn't help us much. So what we did is, and again, since we focus on post-compromise, post-exploit, we dialed down on phase 2, and you can see that's sort of blown up here. You can't really see the text, but effectively what that is we took each category or tactic, technically, from the attack matrix, brought back all that mapping we did for all their TTPs, and broke it down into a flow diagram here. So now, if I was to go ahead and give this to a red teamer, he only has specific options that he's sort of allowed to use. What this does is allow you to focus in on what you believe is this adversary's MO. And not only that, if I give it to 5 people and tell them to run it 5 different times, you're pretty much going to get something really close to an apples-to-apples comparison. And this is, hopefully, I guess a step in the right direction. We went a step further. So, for example, instead of just specifying, schedule task, right? That's one of the boxes in attack. We went forward and we broke out in 3 different columns, basically 3 different ways, or using 3 different offensive frameworks, how you can actually go ahead and schedule a task to do that specific persistence, for example, or privilege escalation. So for APT3, we really focused in on built-in Windows commands. Cobalt Strike, and just Metasploit. APT29, there were some interesting TTPs in there, so we brought in an open source Python rat there called Puppy. I think that's how it's pronounced, but P-U-P-Y. But yeah, and as one of the examples, these are the 2 things you'll find in this adversary emulation plan, the sort of flow graph and the explanation of it. And the second thing with this would be the tool and explanations of the functions that we found within the tool. So for example, OS info, that's something APT3s have been known to use. It's one of their tools, that's what they called it, or has been called. But within each function, we map these, as you can see in the last column, we map that back to attack. So that allows you to basically identify what that tool enables the adversary to do. So okay, I've done this adversary emulation plan. I have one for APT3, one for APT29. I've given it to my red team to go ahead and actuate on. How do we actually, save this data? What do we do with our results? What are our metrics? And this goes back to something Frank was talking about basically filling in the attack matrix at this point. So the shadowed or the filled in colors here, you see green, those are the ones the techniques that were tested and detected, so we're pretty much all good there. Gray are the techniques we did not test, but APT3 have been known to use. Yellow that were tested and weren't detected, but could have been. And red, finally, those are sensor gaps that we at the current time can't just change a configuration or tune an analytic or whatnot. Maybe to actually get that green, we would need to maybe go out and purchase another sensor or work on maybe even developing a new data source that doesn't actually quite exist. There's the idea of execution gap versus coverage gap, the difference really between the yellow and red, and Chris Gates and Nickerson go through that in quite some detail. There's a really good the Brucon talk a couple years ago. If you haven't seen it, definitely go. I think it's up on YouTube, so it should be easy to find.
So I'll just jump in 1 second. So this goes to the stoplight chart that I was talking about before that everybody in management loves to see, right? Super dangerous to put it this way, because that green is like, that's our one instantiation or two instantiations that we tried out. That's what they were able to detect. Like, you can imagine it's almost like a tuple, right, of the number of known implementations of a technique, the number of tested, and the number of detected. So it's actually like got a depth to it that we haven't figured out quite how to handle yet. The other key component is the challenge of attack as a full knowledge base. So we love attack. We eat and breathe this stuff, but at the same time, we recognize its limitations. When Chris and his team were going through APT3 specifically, I think it was about 120% improvement on the number of techniques that were attributed to APT3 since it's been rolled into a new update of attack. But if they were just going and doing a search on attack for APT3, they would have only been able to get a subset. So it really does come back to being able to harvest those threat intel reports, which is definitely a non-trivial thing, and I don't want to underestimate the amount of work that Chris and his team put into to do that. Because to take IOCs or functions and things like that and try to translate that into behaviors is something that's not easy to do at all. And it's one of the things that I would do is like, hey, we're looking for actions to be able to take with us as we go forward. Some of those actions should be, let's start building out threat intel that's actually usable. Let's figure out ways of using it. So let's not just give IOCs, let's talk about behaviors. Let's not just give attack, but let's give ways of making attack actionable with these emulation plans. So that's just the kind of like main driver that we're trying to push with this.
And you brought up a really good point, and using these emulation plans is pretty much a good way to just get using attack as fast as possible. If you're a small just a small team that hasn't really used attack, we've had that question several times. Someone will come to us and tell us, hey, we're really big proponents of your work. We fully agree with what attack's trying to do, and we want to start using it. Where do we start? Just showing them the website, that's not very helpful. But this has been broken down so that you don't need a full red team to actually be able to run an adversary emulation plan based on attack. And because we released APT3, our APT3 emulation, adversary emulation plan publicly about less than a month ago, what we're looking to show is basically have that be a prototype of what's required to be able to develop an actionable plan that your red team can do based on attack, and also what kind of information is required from the intel providers, hopefully to take intel away from IOCs. And IOCs are always helpful, but really they're really quite easy to fix and change. And take that back to or towards more behaviors, which we've seen naturally sort of happen, but although a little slowly. One point I do want to make is, this is something Toby yesterday talked about in his red team presentation. Red teams are expensive, and often there's way too much that the red team members are trying to do. Creating these plans, we've realized, so we've had our red teamers basically create some of these adversary emulation plans and then pass them down to some newer folk, some people with less experience, because they are bound, because they are, there's only so many things, they have to actually do, and a lot of it's not exactly spoon-fed, but they are given a sort of excerpt of the red team field manual to be able to actuate on some of these. You can offload some of this work to what you want to call maybe junior red teamers or just people even. We've had blue teamers do this as well, people developing sensors and whatnot, do it on targeting their own sensors and just basically empowering them to do that. You take that even further down in atomic tests. If you're able to have those TTPs actually down to the atomic test, you can automate that and send it that and continuously test that. That's all this diagram here is trying to show. Just basically how often, if you were to really implement this and take this to heart, how often you sort of might, I guess, aim to start running these tests, the different types of tests. Yeah, so some of the ways that we've seen people automate these things, you could, custom roll your own. Red Canary and Casey Smith's the atomic testing framework, that's a really good way, or a really good step forward, and I've definitely taken it and tried to contribute to it and expand it, and it definitely needs a lot of help, as a lot of these things they're mostly community based, but and I've seen several people here over the past couple of days talk about the automated breach simulation vendors and their familiarity with them. And these are your ATT&CK, your Safe Breach, your Verident. They're good. They come out of the box with a lot of different tests, and you get that nice fancy dashboard that, okay, you failed here, you succeeded here, etc. And some of them are extendable. The one thing that I wish they also were extendable to, I guess, via some sort of API would be is maybe if we were able to actually take this adversary emulation plan and basically be able to completely replicate that within that tool. Yes.
I was just going to suggest it's worth noting that none of the simulation vendors do actual actions on hosts yet. None of them are capable of actions on hosts. They're all pretty good at actions on network. But
So, yeah, thanks. So Verident definitely, sorry, yeah.
Yeah, Verident does do most simulations now. You can run agent on the existing host and allow you to do that.
So, yeah, and thanks. And so all three actually do on host at various levels. Yeah, and that's something we've seen. What we tried to do was take basically the APT adversary emulation plan and fully implement it using ATT&CK and Safe Breach. We didn't quite get the Verident yet, but and we realized that you can run atomic tests. A lot of them you can extend it to be on host. However, anything that really requires state, maintaining state between one or the other, that's where the big failure is. And well, not a failure. I mean, they didn't really focus there, but. So that's where something like MITRE Caldera could hopefully help. This is something we open sourced, I think, about a month ago at Black Hat in London. It's an automated adversary simulation system. It's based on attack. It takes basically, I forget how Doug exactly explains it, but it has a little flavor of AI and basically works on the fact that every TTP needs a certain set of preconditions to be successful, and then after it runs this set TTP, it leaves this, it changes the state of a system with certain post conditions. And if you take this into account, this is something we're currently trying to do right now, and it's just on our near-term plate to fully implement these adversary emulation plans in Caldera, and this is something we're looking to do and release our results pretty soon, hopefully. So yeah, just some of the resources I've talked about. You can find attack at attack.mitre.org. The adversary emulation plans, we've released APT3. That's also under attack, but that's specifically you want to jump right there. Caldera's on our GitHub, and we have 2 email addresses depending on what you're looking to do or reach us for. But either way, they both sort of come back to either Frank or I. And yeah, so really, I think one of the biggest things I wanted from this conference, from this talk, is be able to ask you guys, the people who actually do this kind of stuff, not just for fun or for research, is take a look at these adversary emulation plans, specifically the APT3 one that we've released, and tell us how it succeeds or fails at helping you guys do what you need to do. Let us know how close we are, just anything along those lines. And everything we do in this area is collaborative, and we're looking to build communities around these things. We haven't, I don't know if it's quite open or not, but there's a Slack channel or the whole, server for ATT&CK. So if you're interested in joining that, go ahead or collaborating in any way or contributing, please send an email and then we can get you guys on there if it's not public. But yeah, that's pretty much it. Do we have any questions, comments? Has anyone actually seen the adversary emulation plans in the last push of ATT&CK? Okay.
Yeah, they're awesome.
Thanks.
I've sent it as mandatory reading for everyone on our team and all our volunteers.
Awesome. Yeah.
Do you plan on releasing any more emulation
So,
plans from
yeah.
other APT groups?
So we're still working on 29. The difference between 3 and 29 is actually quite large, and we're looking to release 29 soon. And really, the interesting thing to note is from the time when 3 was active or really active to 29, which is obviously currently active in some capacity, the amount of intel changes. There's a massive amount of intel for 29. There's not as much for 3, so it's sort of easier to go through 3. With 29, I mean, what I'm doing right now, it's out of date, next week, right? So that brings another thing. These are all sort of dated. At a certain point, you've got to stop it there. But in reality, what we tried to do with these, basically release these as a form of a prototype. This is what we're looking for in the community. If these turn out to be actually very helpful in some way, we're hoping that just like ATT&CK, we can turn to you guys to see what you guys want to collaborate with us, and we can push that forward as well. So yeah, Frank, did you?
Yeah, and the much shorter answer is we hope that 29 is going to be releasable soonish. But as he said, we've had it snapshot it, and then it's got to go through the release process, and yeah, but fortunately we've been able to get this out, and I think that hopefully we can get, as he said, kind of the broader public to start contributing as well. Like I know that certain vendors are more familiar with certain groups, right? It would be great if they could embrace this methodology. Or I know Palo Alto's doing their, I think, adversary playbooks is what they call them. And so lots of people are moving kind of in this direction, but we have to continue to enable it and work on it. It's a collaborative group.
Yeah, earlier in the talk you were looking at you mentioned some of the EDR space and how there's consolidation of the feature set. Do you guys actually evaluate any of those tools in your simulations, and do you have anything you want to share about where you're seeing the vendors do good work? I don't know. I don't want you to name vendors, but I'm interested.
So that's definitely something we're trying to work with. It's a new space for MITRE. Trying to engage commercially. A lot of our eval agreements immediately make it so we can't share things besides sharing with the government. So unfortunately, that limits us to sharing broadly. We're trying to figure out ways of developing compromises, either working with vendors so that they can at least say that they're using ATT&CK and using it in certain ways. That's had a little bit of mixed results, to be honest. So some of the next set of activities that we're trying to do is say, can we release a 2-page summary of the evaluation where at least we get to capture our ATT&CK matrix representation of what you were able to do. And I think that hopefully in the next month or two, we're going to be able to continue to flesh out what we can say and do publicly. Because we know that it's going to continue to be a big problem to be able to share and kind of sift through the snake oil that is solutions.
Any other questions?
I will say that broadly, without naming specific vendors or anything like that, right? I think that we do have to be mindful of how ATT&CK gets used. So a lot of vendors will claim like 99% or 100% ATT&CK coverage. And it's one thing to be able to say that theoretically you could detect. It's another thing to be able to say how you actually would detect. So I think one thing that would be great to be able to see the vendors of you in the audience would be to be able to articulate exactly how you do those detections. If you don't have it in your tool with a mapping to ATT&CK, at least be able to release hey, this is how we're actually detecting it. So you're not just showing a green square, you're showing this is how I'm detecting it.
Hi, I've got another question. I work for a firm, and we test the security effectiveness of some stuff when compared with performance. And one of the areas that I work on specifically is with these attack simulation tools. You talked about Attack IQ, for example. We found that we get, the difference between 90% and 99.9% is a huge performance loss. So a lot of times in the real kind of environment, you find a lot of these disabled, either because of high false positive rates or because that performance hit is just not worth it. They're losing so much of their device that they're paying for. Is that a factor in any of this? Because that goes down to money. It's how big of a device are you going to buy if you're going to have the highest security but the lowest throughput?
Yeah, and to be fair, we've purely looked at it from a technical capability standpoint. Right, our engagements that we've done, we've got a blog somewhere out in the interwebs that talks about our process. But right, when we do these evaluations, one of the things I should have said is we do it collaboratively with the vendor, right? They're in the room with us when we do the evaluation. We're trying to improve their product. And it's been great to see certain vendors be able to articulate ways of improving their products, but it's purely looking on that technical capability. We do try to capture like special configurations or scripts that they've brought in to kind of use their tool in more advanced methods, and then try to work with the vendors to say, hey, make those scripts available, make sure that you're advertising to how to use them, and those types of things. But again, it's all based on the technical capability at this point.
And kind of adding on to that, something that we've found is vendors that might cheat a little bit. You'll have filters that are a bit less thorough. Yep. So for example, a flag on things like proof of concept or metasploit or exploit or hacker, things like that. And you will increase your throughput, you will score higher on the security test. Yeah. But if you're using attack tools like that or simulation tools like that that don't have modifiable payloads, they're going to be scoring incredibly high, and they can kind of squeeze by without actually doing all of the work.
Yeah, I think that brings up a very important point, is that it's not just about did you color the matrix, right? It comes down to how was the detection actually done. So even if we get to the point where we're eventually able to release full reports of like how we've engaged with vendors, it's important to be able to say, this was all the red team activities that we did, right? And this was how the vendor was actually able to do the detection or the alert. Was it in prevention mode? Was it in protection mode, right? All those different types of configuration choices and how the detection was actually achieved are kind of how you differentiate a lot of these tools. Because at its basic components, right, they're all collecting the same data. They can sell it however they want to sell it, but they're all doing process, they're all doing file, they're all doing so they all have the ability, but how they actually do it and how much of it's built in is really what's the kind of key differentials.
And just to answer a little bit more about that, them detecting Metasploit, for example, that's not going to fill in anything. Them detecting credential dumping because Metasploit ran Mimikatz, for example, into the reflective loaded PowerShell script, that's going to, if they're able to tell us that's what happened, that's what we care about, and that's the behavior we care about. Otherwise, the tool's just pretty much IOCs, right? Not behaviors. Cobalt Strike, for example, with every update, I think they're making more and more things, changeable, swapping things out, allowing you to swap things out. And out of the box, pretty much all that's going to be detected. That's why we started looking at some other ones, but just for like small little atomic tests. Again, Puppy's pretty cool. Python Rat, you guys, open source and everything, you should check it out. But yeah.
All right. Well, thanks very much. And let's give him a hand. All right. At this point, you ops guys can get out. I'm just kidding. No, we're going to recontinue the ops track over in the main hall area. And then we will, the philosophy track, what we're going to do is actually talk about testing and evaluation frameworks. So how do we actually figure out how do we do this in a more systematic way? So some of the content that you heard today, as well as from Joe Slowick yesterday, we're going to discuss in greater detail as a part of the philosophy track in about 5 minutes. Okay, so 5 minutes from now, we'll start the philosophy track again.